So we have a long division problem here where we have to kind of fill in the blanks. But rather than doing any type of random guessing and checking, we're actually going to solve this using just pure logic. But before we do, I haven't done long division for quite some time. And even when I did do division, I'd always use short division because in my mind, it was just faster. So why bother? Until you get questions like this. So I'm just going to run through a kind of like a long division problem. Let's say 524 divided by 6. And then how many 6 is going to 5? Well, I can't do that. Well, how many 6 is going to 52? Well, it goes in 8 times. And then, well, 8 times 6 gives us 48. And then we do a subtraction. And then that gives us 4. And now bring down the 4, or the next 4 rather. And so, well, how many 6s go into 44? Uh, well, that only goes in 7 times. And then 7 times 6 gives us 42. And then that leaves us with a remainder of 2. So this 2 here is a remainder. Quite often, because I gave this question to a number of my students, this question and variations of this question, and they're quite often default to thinking about this as the answer. But actually, this is not the answer. This is the remainder. And that remainder is actually quite helpful. Because if it has a remainder of 7, what does that tell us about this number here? Well, you couldn't really have a remainder of 7 if you're dividing by 6, for example, because 6 will go into 7 one more time. And hence you would then have a remainder of 1, which tells us that in order for this remainder to be a 7, the number at the top must be an 8 or 9. And believe it or not, at this point, for some people, not me, but for some people, they could answer the question straight away. Answer the question straight away on this one. We'll talk about why later on, but for now, we're going to go through the slower way, which is kind of how I slowly muddle through. So this could be 8 or 9. And so that's one thing. So we're 8 or 9 there. And then if you think about this being a 7, what numbers subtracted can give you a 7? So if we've got a 2-digit number here, subtracted by a single digit here, and this is a subtraction, by the way, because these are all subtractions here, then I don't know what this number is. I don't know what this number is, but I know this must be a 1. I know this must be a 1 because only 10 something minus a single digit will give you a 7. And then if we look back up, well, the same logic applies for this one, because there's a subtraction here. And it's going to be 8 or 9, I guess. And it's going to be a 1 there. And then by extension, well, 2 digits minus a 1 digit to give you 1, well, this has to be a 1 there as well. Now, the other thing is that, well, where do these numbers come from? Well, let me just highlight it. Where do these numbers come from? Where do they come from to start off with? Well, they come from the multiplication. Well, that's this one, and then this one to this one. Which means that this number, the first number, times this, whether it's 8 or 9, comes down to here. Now, if this is 8 or 9, the only single digit that would work is a 1. Because if it's a 2, 2 times 8 or 2 times 9, it's going to give you a 2-digit answer, which means it can only be 1. And then if you consider that, well, this times this gives you this number, well, then this must be 1. And then this times this gives you this number here, which means this must be 1. So you actually have a whole bunch of 1s there. So it doesn't seem as if it's as hard now. Hopefully not as hard. Now, at this point, you could then consider thinking, well, if I change this to kind of like a multiplication, if this were 8 or 9, and it gives you an answer of 1, 1, 1, then if we change it to a multiplication, then 8 times 1, 1 will give us 8, 8, 8. Oops. And then 9 times 1, 1 will give you 9, 9, 9. But this one is a 4-digit number, with a remainder of 7, which means at the end of this, we've got to add a 7. And then the only one that would break the 4-digit barrier would be this one here. So at this point, you can actually just say, well, this must be 0, 0, 6, and 9, 9, 9, 9. Which, well, does it make sense if the 6 comes down? Well, yes, it does, because it's 16 minus 9. And if this 0 comes down, well, that's consistent here, and that's consistent here. And the job is done. And that's kind of the slightly longish way. But if you were to consider the right at the beginning, when you had 8 or 9 here, if you consider the fact that a 4-digit number times, well, a 3-digit number times the 888, and it had to be 111, then it couldn't possibly be an 8. Because if you add on a single digit, you couldn't break the 4-digit barrier. Which means that you can actually start off fairly on with a 9 there. And you can do it fairly fast, basically. But yeah, I think because I gave a number of students this question was quite a fun question. I think there's somebody else who's going to do a video on this one, which is a variation on this one, a variation of them, and this one's a little bit harder because, well, I would say it's harder, but also easier depending on how you look at it. Because this time we only have a remainder of 1, and that tells us that, well, we've got a whole bunch of options there, which means that our approach to this question is slightly different. But I'll hopefully put a link in the video for her so that you can watch the solution done by my student instead.